Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Today we are in the tutorial 11 of Data Science and Machine Learning series. In this session, we are just going to discuss related to the algorithms using Python. Dear friends, an algorithm is a series of instructions that can be executed to perform a certain task or computation. A simple computation in mathematics or algorithm. For an example, when computing the perimeter of a circle, you multiply the radius by 2 pi. So it's a short algorithm, but an algorithm it's actually nonetheless. So algorithms are often initially defined in pseudocode. So which is a way of writing down the steps a computer program will make without coding in any specific language. A reader should not need a technical background in order to read the logic expressed in pseudocode. So here I just given an example. So for an example, if you had a list of positive numbers and wanted to find the maximum number of positive number in that list, how the exact algorithm would be expressed. So set the maximum variable to 0. For an example, for each number in our list, check whether the number is bigger than the maximum. So set the maximum variable so that it is equal to the number. And last, maximum is now equal to the largest number in the list. So pseudocode is useful because it allows us to show the logic of our code in a more universally accessible format than writing in a specific programming language. Dear friends, programmer will often map out their thinking in pseudocode to explore the logic of their planned approach before writing the code itself. Okay, here let me just go for an example how a pseudocode can be written. Here it is the exercise to find the maximum from a list of positive number. And here it is specified in the number, that is here the what is the first number is create a list of number, and next is the set the maximum variable to 0. Look through each number and compare it to a maximum, and last check the result. So this is how the exact pseudocode has been written. And once on executing, so when on just making the pseudocode, yeah, according to that pseudocode, if you just provide the instruction, yeah, here it is in the Python. So if you just give the exact instruction with the condition, yeah, the exact program has been written, and the pseudocode given and found the maximum in the list of numbers. And here it is the list as like 4, 2, 7 and 3, and we get the output as 7, which is the highest largest number. Okay, next we are just going for the algorithm, which is most commonly discussed. Dear friends, this is what which we just say the algorithm, whichever we are just discussing, the sorting algorithm would comes in the first in our mind. The sorting algorithm comes to your aid when say you have a list of values and you want to sort these into an ordered list. So how this program or problem is ever present in our data driven is, first we have to do is you have a database of contact and want to see them listed alphabetically, or you want to retrieve the 5 best test result from a classroom of student, or you have a list of insurance policy and want to see which one have the most recent claim. So here how this begins, the output of any sorting algorithm must satisfy two conditions. One, it must be in non-decreasing order. That is, each element must be equal to or greater than the element that came before it. And second, it must be permutation of the input. That is, the input elements must simply be rearranged and not altered. Okay, let me just take a small example how this can be happen. See, dear friends. So this is my list. Okay, here it is my list, I'm just having 5, 8, 1, 3 and 2. Actually, how this has to be done is 1, 2, 3, 5 and 8. This is what the shorted order. So how the exact sorting happens is, first it just take this two alone, and it just to check which is the, that is, start with the first two element of the list. If the first is larger than the second, then switch the position of the number, and in this case you leave them as 8. Actually, if it is the 5 is the greater or 8 is the greater, you have to move this 8 towards the last. So how this happens? So 5, 1, 8, 3, 2, and again it just checks the 1 and 8, and see here again it is higher, so it just makes 1, 8, 3, sorry, 1, 5, 1, 3, 8, 2. And now the exact checking would be here. It just verified the 3 and 8, and now it just makes 5, 1, 3, and it just goes for the next one, that is 8 and 2, and here it is just makes 2 and 8. And now see here, dear friends, so now as we are just getting 5, 1, 3, 2, 8, now again it just makes the 5 and 1, and see this 5 would be the highest. So how it just makes is 1, 5, 3, 2, 8, and again 1, 3, 5, 2, 8, and 1, 3, 2, 5, 8, and yeah, here no more the things is that. And now when I'm just making this one, yeah, here 1 and 3 is okay, but how this 2 and 5? So here what it just do, it just checks for 1 and it rearranges this alone. So 2, 3, and now it just check, yeah, it would be the shorter manner. So this is how the exact sorting happens. Let me just see it with an example, dear friends. This is one of the sorting which we just say with a bubbles sort, and we are having a number which we just compare it to the maximum. So how this is happening is, yeah, with the swapping only. So here let me just have our list number the same 5, 8, 1, 3, 2. So we are just taking it into the variable L, and yeah, still swapping, that is it, whether it has to be swapped till, if it is true, yeah, it has to continue further for the next iteration. So this is being initialized with the boolean true. And see here, dear friends, this is the exact function which we are just checking for whether it is the highest or not. So this happens when it just makes the exact finalizing which should be done, or whether it is all the exact list is it sorted manner or not. And see here, dear friends, once for all, if I just call for this function, and this is the exact result which it just gives the list in a sorted manner. Fine. Next comes the one which is an algorithm, which we just say as searching algorithm. See, dear friends, another important family of algorithm is the searching algorithm. In a world where you are producing an exponential increasing amount of data, these algorithms have a huge impact on our day-to-day lives. So simply considering the size of Google should give you an appreciation of the importance that is of these algorithms. Of course, you encounter the need for this algorithm just about every time you pick up any gadgets as like a mobile or a laptop. How just make it, yeah, you search for your contact list to send any message or to make a call, or searching your system for a specific application, or searching for an email, contacting anything related to your business. So with any of these example, you can apply the simplest form of searching, and that is a linear search. And yeah, this will involve simply looping through all possible results and check whether they match the search criteria. So for example, if you were searching your contact list, you would look through each contact one by one and each check whether that exact contact met the search criteria. So if so, return the exact position of the result. This is a simple but inefficient algorithm where with time complexity of O of n. And see here, dear friends, when I'm just going for this linear search, how this happening? So the same, let me just have the same list L, which the list of numbers is 58132. And now what you want? I want to search for a value 8, whether it's there or not. And see here, dear friends, it just going to create the list variable that has a default value of -1. So if the search is unsuccessful, this value will remain -1 after the algorithm is executed. That is what I have just given in the commentary. And if the value equals the search value, it just sets the result and exits the loop. That is, it is available or it is existing. So let me just check for the value and see here, dear friends, when on just present, it just going to return as 1, and when on just not present, it is just still be as -1. So let me just make use of this exercise to make the linear search. So this is what our list, and we are just going to search for a value 8, and we are here to initiate the value of result as -1, and this is the exact loop. We just check whether the exact value is available or one among the list or not, and see if it is returning 1, yeah, it is seems to be, yeah, existing. If it is not, it just makes us -1, and here we are just getting the 1 in positive, so we are having that value in our list. Yeah, next, going for a binary search. Dear friends, how this binary search will exist? So another common example is that. So let I just go for a new. So see here, dear friends, how this is happening. So this binary search is an algorithm which takes a sorted array and finds the position of the target value. Okay, suppose let me just have, this is our list. Okay, and in this list, what we are just having is 2, 3, 5, 8, 11, and 12, and last it's 18. And see here, dear friends, how this is happening is, I just want to make, let me just identify whether the value 11. Okay, so the value 11 is there in the exact list or not. So this is what we are just going to search it, and in that, how we are just going to explain it. Let me just take, so take the midpoint of the list. And what is the midpoint? Yeah, this is the midpoint. Okay, and if this value is less than the target value, discard the left half of the list. And in this case, our target value is 11, which is greater than this. So it is just going to go in the side of the left side. And see here, dear friends, we already know that since 8 is the exact middle, and so you know that you can restrict our search for this right side. And let me just move on to the search here in the left side, and see, you know, the array is sorted. We know this is the exact array which we are just having in a sorted method. And see here, dear friends, if there is any even number of items, here we are just taking 8 as a mid number. Here we are just taking 8 as a mid number. So from this we can just say whether it is less than or it is greater than. If there is an even number of the list, simply take one of the two middle number. It doesn't matter whichever it is. So even though you can just take it here or you can just take it here if it is even in the sense. Okay, so now when on just making this, you're just going to make the exact search onto this and not here. So how my list, it would be just blank onto this side. So here we are just making the midpoint of 8 and rest we have to search only in this list according to the binary search. So binary is in the sense any one of the way, any one of the side. So you repeat this process with the right side of the list by picking the mid of the point remaining values. So as we here we are just having to this level what we just have. So to this level we just have 11, 12 and 18, and now this is the midpoint. And now just check, we want to check for the value 11. So whether it is less than this one, or that is with this exact midpoint is less than 11, or sorry, less than this midpoint or greater than this midpoint. Actually it is less than the midpoint, so it just goes to this and identify whether this is the existing, is this the existing one which you are in searching for. So this is what it just leaves, because it is just going to eradicate this one and here it is just missing, and this is what the element that is left over, and just check that is what you were searching for. So let me just make it through the coding here. See here, dear friends, this is the same list which we are just having, and how this is happening is, kindly just have a look of it. So the exact element which we are having is the list is 2, 3, 5, 8, 11, 12 and 18. So let us just execute it. And what we are searching for? We are searching for the element 11. So let I just execute this. And since see, actually here we are just creating two variables that will represent the start and ending location of the sublist. Okay, so you are interested to in, so which you want to make use of it. So this initially it will represent the start and end indices for the entire list. Okay, so here we are just having two things. One is start is equal to 0, and we want to make as the end where the length minus 1 would be the exact indices, because we are just want to make with the index. Okay, so let I just execute this. And yeah, anyhow, as in the previous, we just made whether it's found or not, whether the searched item is there or not. So there we specified that is initialized with -1. Here we have to provide it with a boolean. So here we are just providing it as a false. Nothing much different is there. So don't worry here. And next, going on to that, find the midpoint of the list. So wherever till it is searching, so it is still the exact list. If it is empty, till that we are just going to repeat this. How come is check whether the value is greater or lesser than the search item. Depending on the outcome of the comparison, either finish the search or update the location of search that is coming with starting or ending of the sublist. So this is how you have to make use of it. And at last, whether it is found, or whether if it is found and what is the location. So here is it is found, yeah, it is true. And what is the location? Actually we are in search of 11. I just scroll a bit above. See here, this is what our 11, and see this is the induction I have. I just want to search for the location. So the indices, it just starts from the 0. So 0, 1, 2, 3, 4. So we are in the position of 4, that is the 11 is presented in the fourth location. So here it is how you can just get over. So you found 8, and yeah, it's returned in the boolean as true. And yeah, what is the location? It is 4. So this is how, dear friends, we have just seen few algorithms, and take this opportunity to subscribe the channel and never miss any updates. Thank you, dear friends. Have a nice day.